Hi, this is the solution to homework set number 13 for ECE 111. In this homework problem, we're trying to find the voltages for a diode equation, for a diode circuit. The circuit's right here. Here's the diode equations. For a diode, the current is related to the voltage across the diode. So three of the equations are just the diodes. The voltage drop across the first diode is V1 minus V2, so they get substituted up here for VD. The second diode is V3 minus V4. Third diode is V4 minus 0. So the first three equations you're going to get are just these. The next set of equations are the voltage node equations. The current from node 1 adds to 0. That's your V1 minus V0 per 100. The current down, which is just ID1. Current through the 200 ohm, 300 ohm, 400 ohm resistor. Likewise at node 2, I've got three terms. The current through the 600 ohm, 500 ohm, minus ID1. At node V3, I've got the current up, V3 minus V2 over 500, plus ID2, plus the current right, and likewise for V4. So the next set of equations would be as follows. Note when you write the equations, at node 1, all the V1s are positive, everyone else is negative. At node 2, all the V2s are positive, everyone else is negative. There's also symmetry. I've got this term between node 1 and 3, V1 minus V3 over 200. Its counterpart, V3 minus V1 over 200, appears on the node equation for V3. That's one way to check your answers. So altogether, that gives me 8 equations, 8 unknowns. In MATLAB, I can solve. I'm going to guess my voltages, V1, V2, V3, V4. From those, calculate the currents through the diodes. From those, calculate your node equations. And instead of making the equations equal to 0, I'll make them equal to an error. Error 1, E2, E3, E4. Return the sum squared error. If I can minimize the sum squared error, make it 0, I've got the right voltages. That's what fmin search does. It says, minimize this cost function. Here's my first guess. And it'll sit there and iterate and try to force the sum of the squared errors to 0. It helps to have a good initial guess. And what I guessed is initially each diode is 0.7 volt drop. So I guess 0.7, 1.4, 2.1, 2.8. In theory, it works for any guess, but again, it helps the algorithm if you get something close. So these should be the voltages. If you go into Circuit Lab, you can do the same thing. If you input the circuit in Circuit Lab and tell it solve, what it will tell you is the same thing. So this is the Circuit Lab solution. Here's the MATLAB solution. They're slightly different because the diode used in Circuit Lab is slightly different than the diode we used, but they should be similar. When you get to electronics, that's a common theme. The voltage that you calculate will be slightly different than the voltage that you simulate, will be slightly different than the voltage that you measure in lab, because they're all slightly different diodes, but they're all very close. A silicon diode has about a 0.7 volt drop across it, and that's what you're seeing here. So that's homework set number 13 for ECE 111.